Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from integrals. And in this session, we are going to discuss this problem where we are given a function g of x that is given by this integral 0 to x, and the integrand is cosine 8t, and here we have dt. Then we have to show that g of x is equal to g of x plus pi, right? So here in order to show that g of x is equal to g of x plus pi, where g of x is given by this integral, we are going to make use of the concept of the first fundamental theorem of integral calculus, which is also known as the fundamental theorem of calculus part 1, right? So let us first see the statement of the first fundamental theorem of integral calculus, and then we'll apply the same to this problem. So the first fundamental theorem of integral calculus says that if f is a continuous function on this closed interval a comma b, and some function say capital F of x is defined by this integral, that is from a to x f of t dt, where the lower limit is a constant, that is here we have a, right? And this function f of x is also continuous on this closed interval a comma b, and this function f of x is differentiable or derivable on this open interval a comma b, and the derivative of f of x is given by that is f prime of x is equal to f of x, right? That is f prime of x is given by d by dx of this integral, that is a to x. Here we have f of t and dt. So this derivative is equal to simply f of x, right? So this statement is known as the first fundamental theorem of integral calculus, and we are going to apply this result to solve this problem, although we can solve this problem by other methods also, right? So now if we compare this expression with this one, then capital F of x is given by g of x, and here we have the integral from a to x, here we have 0 to x, so the value of a is equal to 0 in this case, and our function f of t is given by cosine 8t, right? So here we have f of t is equal to cosine 8t, right? So now let us make use of this result. So here if we differentiate both sides, then according to this statement we have d by dx of g of x, that is we are differentiating both sides with respect to x, and here we have d by dx of 0 to x, and here we have cosine 8t and dt. So here we have a g prime of x, and here according to this statement the derivative of this integral with respect to x is simply given by cosine 8x, that is this t is replaced by x, right? So we have g prime of x is equal to cosine 8x. So we can now have a differential equation here, that is differential equation of first order and first degree. So let us now solve this differential equation. So we can now again write here d by dx of g, and here we have cos 8x, right? So here for g of x we are simply writing g. So now we can write here dg is equal to cos 8x dx, and now we can integrate both sides. So we have here integral dg, and here we have integral cos 8x dx, and c is the constant of integration, right? So here we have simply g, so let us write it as g of x, right? So g and g of x are same. So we have g of x is equal to integral cosine 8x dx, and from indefinite integrals we know that integral cos ax dx is given by sine ax over a, right? So here the value of a is 8, so we have simply 1 over 8, and here we have sine 8x plus c, right? So our function g of x is now given by this expression, so let us call it equation number 1. So now let us replace this x by x plus pi, right? So we have g of x plus pi is given by 1 over 8, and here also we'll replace x by x plus pi. So we have sine 8 times x plus pi, and c is the constant of integration. So now we can write g of x plus pi is equal to 1 over 8 sine, and here we have 8x plus 8 pi plus c. Now let us now express this expression, that is sine of 8x plus 8 pi with the help of trigonometry. So now from trigonometry, we know that sine 2n pi plus theta is given by sine theta, where n is some integer, right? So here we can now write this expression, that is sine 8x plus 8 pi as sine 8 pi plus 8x, right? So we can now write here 8 pi as 2 times 4 times pi, right? Because here 2 times 4 is 8, and here we have 8x. So now if we compare this expression with this one, then the value of n is equal to 4, and our theta is given by 8x. So this expression is now of this form, that is sine 2n pi plus theta. So according to this rule, here we can now write simply sine theta, and our theta is 8x. So here we have 8x, right? So now we can replace sine 8x plus 8 pi by sine 8x in this equation. So we have now g of x plus pi is equal to 1 over 8, and we have sine 8x plus c. Now this is our equation number 2. So now if we compare equation 1 and equation 2, then we can see that the right hand side of both these equations are same, right? So we can now write here g of x is equal to g of x plus pi, and this is our desired result, because here the right hand side of both these equations, equation 1 and equation 2, are same, so the left hand sides should also be equal. So viewers, this is how by the application of the first fundamental theorem of integral calculus we can easily solve problems of these types.